take a beat while we get the next set of slides up. Next, we'll be hearing from Kira Barton and Dawn Tilbury on integration of artificial intelligence in manufacturing systems.
Okay, great. Thank you very much. Okay, so our environment's a little bit different from the last one we just saw. It's a little bit more constrained. But what we're interested in looking at is there's a lot of machine learning that's done in a manufacturing environment. And in this talk, we're talking a little bit about how we're thinking of sort of what's the next level, where do we want to get to in terms of being able to really take learning. And so smart manufacturing is really this Industry 4.0. It's sort of the concept we're in right now, which is this idea of taking all of the data that we have access to. Interestingly, it's oftentimes it's very skewed in terms of what we have that's based on normal data and what's based on abnormal data. But that's kind of a current problem that we have. And what we're really looking in this talk is to think about sort of what's the next phase. So if we just look at AI and manufacturing, we see that this is a growing topic. It's used in lots of different ways. Actually, there's supposed to be a picture. Maybe it'll come up in a second. That there's a lot of different applications where we see this being applied. Actually, I don't know where my, there we go. And it's just been growing sort of exponentially over the years. And so more and more data is being collected, more and more companies and different industries are starting to use this information and think about how to sort of effectively use it. But there's a couple of things that sort of prevent widespread adoption. And some of these are listed here. There's a sort of lack of precision or believability, actually. So it may be that the sort of sometimes lack of transparency becomes something that is a big hindrance. And so this is also something that we work on and try to think about is how do you bring some of the, say, human knowledge into what's happening so that it becomes explainable, much like what you saw in the previous talks, which is that you know, it's one thing to have the data and the numbers, but it's another to be able to explain what's happening and put that context in there. And that's very important. And then there's also some structure, a lack of some structured methods for enabling active learning. And we're going to talk a little bit about what we mean by active learning in the manufacturing environment. So our vision really is that what we'd like to be able to do is go beyond what are predefined capabilities. So as you might imagine, a manufacturing environment tends to be pretty constrained because it's very, very driven by essentially throughput, okay? And so what you need to be able to do is you need to be able to explain what you're seeing and you need to be able to react and respond to it as fast and as quickly as possible. And so what this does is this often ends up introducing constraints around what's allowed in terms of sort of learning beyond that initial capability. And so what we'd like to do is to work on systems where we can try to extend beyond this and learn potentially new ways to do something. And so the tried and true isn't necessarily the most effective or most efficient or most energy efficient to meet the objectives. So another thing that we really work on and stress is this, again, this integration of our AI system and human working together. And this is really important, not only for sort of adoption, but actually there's a lot of information and knowledge that's there that needs to be connected back to the data and to our explanation of what's happening. A big reason for you know, where we're seeing this is there's this huge push, right, for personalized production. So some of that kind of traditional techniques of a mass production type of capability, we're really away from that. We're in these personalized requirements. We also need much more flexible routing and scheduling. Obviously, we've all been aware of what's been going on with, for example, supply chain. Right, so this need for resiliency in the system and that ability to be able to react and adapt to different kinds of disturbances and disruptions is really important. Okay, and then the last piece is that we're really transitioning actually out of Industry 4.0 into Industry 5.0, which is all around sustainability, resiliency, and this human-centric piece. And so how do we think about all of those and incorporate that into the way that we're going to leverage and use information and data and learning to advance our systems? So we sat down and thought about a roadmap towards developing this sort of flexible and adaptive system. And we looked at what's been sort of done over the years and kind of our projection of where we'd like to go. And so if you see along the horizontal axis, that's dynamic decision making and learning capabilities. And on the sort of tilted vertical axis is that adaptability and flexibility. And so our vision is that we want to have a flexible, adaptable manufacturing system that can learn and make decisions in a dynamic environment. So here's sort of our projection, and you can see different sort of paradigms of manufacturing over the years. And so computer-aided manufacturing, it was a long time ago when that sort of was introduced. It was a little bit less dynamic and therefore also less able to adapt. And then you can go all the way down the pathway towards multi-agent, which is a distributed approach, and actually a lot of the concepts of this adaptive learning build off of this sort of capability of having this individual agent identity and thinking about how do you make decisions not just centrally, but how do you start to do this in a distributed fashion. And so that's really the direction where we're going. So if we break this down into kind of a way of thinking about how this would work in our manufacturing environment, we look at each of the different components within the system as an intelligent entity, or what we would call in turn an agent. Okay, and within that agent, it has a dynamic knowledge base, and so that's really its information not only about itself, but actually about its environment as well. And then it is able to make decisions based on that. And those decisions can be negotiations. They build into it constraints that are available or that it understands about itself or about the environment. And so each of these components within a manufacturing environment would fall under different agent categories. This includes parts. This includes the resources like the machines. It includes maybe at a bigger level a cell. And so that could be comprised of multiple different machines and, say, a robotic pick-and-place system. And it can also include individuals. Okay, so a human is also an agent in the system that provides a capability. In this example, it could be something like maintenance. And so a capability we define as an action that the intelligent component or the intelligent agent can perform. And then a capability boundary condition, and this is really the part of the crux of sort of the current setup, is that there are conditions under which this agent has the ability to perform a specific capability. And what that means is it's sort of what are you allowed to do? Okay, if you think about it, it's like setting the rules. Okay, and in an environment, in the manufacturing environment, those tend to be fairly rigid. Okay, and part of that is done for throughput, part of that is done as safety. And so the idea is to think about how that boundary condition impedes or could be leveraged to expand our implementation of an adaptive learning. So we take our capabilities, we have this boundary set for capability, and inside of that boundary set are known capabilities of our system. Okay, so these are things that are already predefined. And so this is an action that we allow and we are aware that the agent is capable of doing. So when we think about adaptation, what we're thinking about is, okay, how do we change behavior within this? Typically, we think about it as how do we change it within this bound? Okay, and there's lots of different ways that we use, say, machine learning to think about this. And usually that is comprised of learning how to do something that we already know how to do, but maybe it's when do we transition to that, or when do we shift to that capability. But what we'd really like to do is we'd like to go beyond that and think about how do we acquire new knowledge or skills. And so this is what we term implemented learning. And so this is an execution of learning that can result in changes in that knowledge base. So we could have a bounded implemented learning. And so what this really means is that we are learning a new capability, but it's within that bounded range. And so this is something that is, ideally, this would be allowable, but maybe it's a capability that we hadn't previously determined within our agent set. And so this has, some restrictions to it, but it actually is a little bit more of a safe sort of learning environment. The other type is an exploratory implemented learning. And so this is where this would be more typical of actually what a human would traditionally do, which is to look at what's there, look at the things that you potentially could do, and then when you think about somebody saying, think outside the box, that's really what we're talking about, right? So could you come at it from a totally different perspective? Could you come at it from a totally different viewpoint that is maybe completely outside of what we're already thinking? And so it moves actions beyond this, or it reestablishes the bounds, resulting in something that was not part of its previously understood boundary condition. And so that's where we've gone now outside of that. And that's really what we'd like to move our learning towards, is how do we start to try to reach outside of these boundaries and think about the problem in a different way? And how do we enable that in this environment that already tends to be fairly constrained in terms of thinking about allowing for things that are a little bit non-traditional. So there's a lot of benefits that we see in this, and so here's an example of how we could think about what this might look like really simply. So we have a case where we have something that's happened, we have no learning, we have a suboptimal performance. We go to a bounded one. Now maybe we learn something like we can do this faster and still maintain our safety requirements, and so that's good, but it's maybe not optimal. Then we can go to the third case where maybe we try to expand beyond, and so we are given some allowable performance capabilities, and so now we can go beyond what we've already done. Maybe that comes up with a good idea, maybe it doesn't. That's actually still okay. That at least gives us some insight and knowledge about what's possible. And then we would, potentially come up with an optimal schedule. And so we can see across the spectrum that, from left to right, we're going towards something that's more dynamic and more flexible. So just to speed this up a little bit, we have some requirements that we've defined for this. We have some objectives for what we want to do, and there's a paper that talks a little bit about this. In the group right now, the way we're starting to think about applying this is that we start with our robotic platforms. So we have a number of different robotic systems. These are primarily collaborative robots, and so these also allow for human interactions, and we really look at how do we put these together with different kinds of capabilities, and we can rethink what how they come together in groups and leverage their knowledge to be able to accomplish something. And so here's an example where maybe we have a robot that's able to do something historically. It takes some of that information, and now it's going to apply it to think about a cooperative task, ideally with maybe, say, a human in the loop. And so combining these different, basically thinking about how do we leverage information and data and use it in this intelligent architecture to get to the point where we can do something interesting together. And so this is just some of the equipment we have in our system. So we have a lab over in the robotics building that's all instrumented up where we can collect information. As I said, we have a much easier environment in some sense to work with. So we can collect a lot of different data, and we're sort of moving towards these ideas of implemented learning. Okay, thanks.